tell I just did like right here.
Yeah.
Hi, my name is David Wright. This year is my 2000 Ford Focus. I call her Anya. I've had the car since about 2008 when I started driving in high school. I learned to drive in it. And ever since then, it's been more of a father-son project car, if anything. I've done numerous performance improvements, which have both made it more reliable and less reliable in some respects. Overall, it's a great car. I believe that it truly embodies the term driver's car. Overall, the modifications I've performed on it are, of course, the general header, intake, all that. The engine is in great shape. Performance-wise, it puts down a lot of horsepower, roughly around 152 horsepower, compared to the meager 77 horsepower the engine had originally. Overall, it's had major modifications to the valve train, certain engine components on the internal side, and it's been performance tuned by FS Works in California. The engine's not even the real good part. The transmission's brand new. It's a high performance unit with a spec stage 2+ clutch. The suspension is where the real stuff happens. Fully adjustable suspension in the rear. Front, I can adjust 3 to 4 different variations. I can also set up custom dampening, and the ride height is fully adjustable. I can go from soft on one day to track ready and stiff suspension on the next day, but the custom dampeners are fully adjustable. I do not have coilovers on the car because that would reduce the drivability of the vehicle. So it still has variable suspension on it, coils and struts, but it's been finely tuned to dial in the performance for my needs. The car has seen autocross, a track day or two, and the streets of Louisville, Kentucky, and out here in Carbondale. So this is my car, and today I'll be talking about how chassis stiffness affects suspension handling and the drive and feel of the vehicle. Thank you, and I hope you enjoy this video presentation. Alright, this here, the heart of the car. It's a 2-liter split-port engine. Roughly about 20,000 miles on the unit since I put it in. The car has, on the body, about 140,000 miles. Here you can see I've got Massive Speed System, one of my sponsors, high fire wires, MSD coil pack for high ignition output and larger voltages, Volant cold air intake with a pro filter and an outer wears pre-filter so that the water coming straight through the open air hood doesn't get any water into the filter and it just beads off with the nanotechnology. Here I've got a high performance power steering pump, metal lines for the power steering, hood pins for when I have my carbon fiber hood equipped to the car, FS Works strut brace, 41 pound-hour injectors of an SVT Focus, SVT high pressure coolant cover. On top of that, the engine has forged rods by Crower Racing. They're H-beam style. SuperTech forged aluminum pistons. Under the valve cover, I have Harlan sharp roller rocker arms, a Cosworth heavy boy camshaft, dual valve springs, and oversized valves. From the exhaust to the intake manifold, the ports have been port matched, allowing better flow. Same with the intake manifold to the cylinder head. I do not run with a catalytic converter on the car because in the state I live in, Kentucky, there's no emissions requirements. The throttle body on the engine is a 70mm throttle body compared to the original 40mm setup that came with the car. The engine's crankshaft is knife-edged to remove excess weight and increase performance. The lower rotating mass allows the engine to rev up and rev down quicker. The compression ratio on the vehicle is 12.1 to 1. The original compression ratio for this engine was roughly 9.2 to 1. So with the higher compression ratio, It yields more performance with less work. Other than that, most of the car is relatively simple.
Here, of course, is the front of the car. Up front, there's a light bar that I built so that I can use the car in nighttime on back roads. First, you can see the front harness bar going from strut tower to strut tower. At the tips, you can see the adjusters for the strut tops right there. What it does is it triangulates the front end of the car, allowing it to distribute the forces of the road evenly. Now, let's take a look at the back. In the rear, there's a very heavy-duty bar triangulating the forces between the strut towers, as you can see here, and right over on the other side right there. What it does is it also triangulates the rear end, preventing the strut towers from wanting to come into each other. Overall, it makes for a pretty competitive car. Big brakes, larger wheels, and high visibility headlights. Other than that, in the hood, there are vents to help excess heat get out of the car, as well as front mud flaps to prevent rocks from being kicked up.
Go. Currently, the suspension is set to the softest setting on the vehicle. Also, this shot, the strut bracing and everything else, after we changed the suspension, we pulled out the strut bracing. As you can see, there's more roll in the body when taking a corner compared to the previous video.
After completing all the tests, I believe that this video can conclude that running a car with bracing to enhance the structural supports and strengthen the chassis, make it more rigid, does increase the ability to handle, as you can see in the video footage before. Also, having a stiffer suspension on a car can lead to a higher rate of performance in handling, but also at the same time, a stiffer suspension is not going to be the most comfortable. With the soft suspension and just the bracing, you can still see a major improvement in the handling of the vehicle. In the PowerPoint slide, you'll see that there's a comparison between time trials, where I ran a certain section of road with similar conditions, both temperature and weather, and similar running conditions with the same amount of fuel in the vehicle to maintain the same weight. And you can see that the times set favor the stiff suspension with structural bracing, almost by about 6 to 7 seconds faster. In conclusion, we've covered structural stability, shown you my test vehicle, my Ford Focus, and I hope that this has helped you get a better understanding of structural integrity of a vehicle and how you can increase the steering and handling responsiveness of a car by strengthening it. Thank you very much. This concludes my presentation.